Okay, well, what if they give it to us in the form of ordered pairs? Now, with ordered pairs, you can maybe just look at these ordered pairs and tell which is which, or you can draw the input and output circles yourself and then start listing. So let's go up here to the first one, and let's list all the x values over here in the domain or the input. So I see 2, 4, 3, and do I list the number 2 again? Right, I got 2, 4, and 3, but I got the number 2 again. Should I list it again? You really don't want to, because that can fool you into thinking it's a function when it's not. Now let's list the output values, or the y values. I see 3, 1, negative, 1, and negative 2. Okay, now let's draw the relationship with lines. 2 gets sent over to 3, 4 gets sent over to 1, 3 gets sent over to negative 2, and so far it's a function, but here's the kicker: 2 gets sent over to negative 1. So 2, the input value, gets mapped with, or mapped over to 2 output values. That's no good. So at this point we're saying this isn't a function. Now pick a point in this first set and tell me which of these points up here could I get rid of to make it a function. Well, you could either get rid of 2, 3 or 2, negative 1, right? If I got rid of 2, negative 1, then it gets rid of this output value and it gets rid of that line. Now we have a function again. Okay. So what does this look like graphically? Like if I were to graph this, what would this look like? Well, let's take those points we just had. We had, I think it was like 2, 3, we had 3, 1, maybe it was 4, negative 1, I can't remember, and maybe 2 and negative 1. Okay, well, which 2 were the points that I had trouble with? Yeah, I think that I had trouble with these 2 right here. So let's keep those, and I'm going to get rid of the rest. And then notice one thing about these 2 points. What do you see? Well, I see that they are in a straight line, and that is basically what's called the vertical line test, okay? What that means is that this input value right here of 2, x equals 2, gets mapped over it. It gets paired up with 2 different output values. So see, I have this output value of 3 and this output value of negative 1. So it's not consistent. I don't know. When I put in the number 2, what am I going to get back? Could be 3, could be negative 1, not consistent. Okay, so let's take a look at this maybe in a different type of graph. How about right here? How about we've got a sideways parabola, function or not? Okay, well, some teachers call it the pencil test. You can just take your pencil and put it over the graph and see whether or not it's a function. You can see we already have a vertical line drawn, which is the y-axis, and that vertical line tells a story right there. I'll draw another one for you, right? And I really don't like it when the software does that, but it tries to correct my drawing, but it doesn't need correction. Okay. So it intersects twice, and that's what I don't want. The vertical line test means that every point in the graph, if it's a function, I should only hit the graph once. But here I'm ending up hitting the graph twice, so it's not a function. Let's take a look at another one. How about this graph? Okay, well, can you find a vertical line to draw anywhere that would hit it twice? See, I can't. I see we got a line here, there's another one here, here. Everywhere I draw these vertical lines, it's only hitting the graph one time. So this is a function, okay? Like if the book says, is this a function? You'd say, yes, absolutely, that's a function because it passes the vertical line test. Okay, let's try another one. How about this graph? Almost looks like the one we just did, but turned on its side. So is this a function or not? Well, look, I can draw a vertical line over here, and that vertical line only hits once. So is it a function? Well, check out the y-axis, right? Or I can even draw my own line here, and this hits 1, 2, 3 times. So that is actually no good. That is not a function. Okay, so we could say not a function. Okay, that's pretty easy. Just a couple straight lines to draw, and that's it. Now we're talking about functions. Let's talk about the new function notation that we're going to be using. Right now, Sorry, hit that button a couple extra times. If you remember, what we used to do is we used to look at this, like y is equal to x minus 2, okay? And what we remember, like going back to graphing, you'd make a table, and the table would look like this, and you had your x values, which are the ones that you picked, right? You picked like 5, 6, 7. Well, those are the numbers that you needed to pick first, right? Those are your input values. So what we can say is that we understand that the y values completely depend on the x values, right? So the y values that we're going to get are completely dependent on the x values. We need the x values first in order to get our y values. So what we do is we're going to look at this notation now, where instead of writing the letter y, or the variable y, we're going to write this new notation that looks like f parentheses x. And what it means is that y, this old y value, is a function of x, means it completely depends on x for the value, okay? So we write it in such a way to show that this function is completely dependent on its input value of x. Now, this is not f times x. I don't need to divide by f to solve for x or anything. Don't need to do that. It's just notation. You could say function of x, or sometimes the shortcut is to say f of x, right? Now, if I wrote it like this, if I had a g, and sometimes books will do that. They'll write different letters for the function to distinguish between the two. If I wrote g, then it would be called g of x. Or sometimes they use h, because if they're talking about more than one function, they can't call them all f of x because you might get them confused. Okay, so we would say f of x. So in this case, f of x is equal to x minus 2. Now, look at the graph there, or the table there on the side. Let's look at this value of 5. If 5 is going to be my input value, then I'm going to put 5 here in place of x, and that's saying that everywhere that I see x, I'm going to put a 5. So 5 minus 2. So this says that f of 5 is equal to 5 minus 2, which is 3. Okay, so it's not that hard. And if you notice, I just left it f and then parentheses 5. Now you could do it again, and this time you could pick the value, right? This was 3. You could pick the value 6. So instead of 5, I'll pick 6, and it becomes 6 minus 2 is 4. So I'll put 4 there in the output value. So what I'm saying is f of 6 is 4. And that's really it for function notation. The book's going to ask you to do a couple of these where they give you a function that looks similar to this, and then they ask you what the value of the function is with different input values. So hope that helped, and we'll see you guys tomorrow. Take care.